Processes classification and evaluation. There are different processes at each side of the cloud and in each level of each cloud's system. We used as reference the processes' signal description and their property. This subjective classification is based on an examination of vertical profiles, shown in figures 4, 5, and 6, and on the shapes of PSDs associated with the near cloud region at each level. The 300 meters passes were only evaluated for evidence of removal by precipitation. Pattern D summarizes the frequency of each category. There were 49 classifications made on Mr. days and 35 during HG days. A classification could not be made in 10% of the Mr. cases and 5% of the HG ones. The largest fraction of the observations was classified as Pattern A, 40% and 60% of Mr. and HG cases, respectively. Pattern C matched only 4% of the Mr. observations and none during HG days. Patterns B and D were equally represented during both Mr. and HG days. Percentages of cloud processing signatures, derived from vertical profiles of particle properties and evaluation of particle size distributions, for the Mr. cases, bottom panel, HG cases, middle, and combined cases. There were no consistent trends with altitude between Mr. and HG days. Particles at 1,000 meters and 2,500 meters altitude were predominantly like Pattern A, in both the Mr. and HG cases. In Mr. cases, there were slightly more Type B than Type A particles at 4,200 meters. In HG cases, the 4,200 meters particles were evenly distributed between patterns A and D. Particle composition estimation. The refractive index was used to estimate the particles' composition at the ends of the clouds. We calculated an average refractive indices at 500 meters from the borders of the cloud. Shows the results. The refractive index profile for the area between 1000 and 1500 m away from the border of the cloud is also shown. This area is considered free from the influence of particle processing by clouds. We consider 3 refractive indexes as benchmarks. The refraction indexes of water, 1.33, ammonium sulfate, 1.48, and sodium chloride, 1.54. Another factor we take into account is the size distribution and composition of particles as a function of their height in normal conditions without the influence of pollution. The type and composition of particles depend on local sources. Thus, in sea areas the main sources are the production of salt particles from the surface of the oceans that are caused by wind friction and breaking waves. These particles are mainly in the lower parts of the troposphere near its source. In the upper troposphere, main sources of particle are the conversion of gas to particle and deposition by clouds, Hobbs, 1993, which produce small particles, less than 0.1 m. In marine areas the particles are composed of sulfate, because they are formed by the condensation of SO2. Particles ranged between 0.1 to 1 microns are composed of sulfate, Hobbs, 1993. Based on the sources we expected to find high ammonium sulfate in the lower troposphere. Derived refractive indexes for far and near cloud vertical profiles for the maritime, Mr. day cases. In estimating the composition of particles from optical counters measurements, the environmental conditions can strongly influence the outcome. Shows the comparison between the dispersion coefficients obtained with the nephelometer and the dispersion coefficient calculated from the particle size distribution. Data were collected on transects at 2,500 meters without pollution, right, and with pollution from the continent, left. The reference line 1:1 is used to compare dispersion coefficients calculated and from nephelometer, assuming 3 different compositions. Left shows that polluted cases at the same height had calculated coefficients higher than those measured with instrumentation. This may be due to anthropogenic particles that absorb and scatter light. So, the measured values will be lower than calculated, since it is not taken into account the particle's absorption. Moreover, no polluted cases have a better correlation because marine particles do not absorb light. This feature allows us to use this technique to more easily estimate the composition of particles in cases without contamination.